Go.
Okay. Hi everyone. I'm not sure whether you have seen the lotus leaf here. Maybe lotus leaf is not common in America, but it is really common in China and India. After raining, you will see the water drop will just stand right on the surface. We call this phenomenon hydrophobic. Also, in contrast, when it's raining, you will find that your car windows will be covered by the water layer. We call this, the car window is hydrophilic. Maybe you will think these two terms is really strange to you, and you don't know how to correlate these two terms to corresponding phenomena. So right now, let me teach you how to do that. It's quite easy. First of all, we see the structure of these two words. These two words both have the same prefix, the hydro. Hydro means water. But you will find that the difference between these two words is their suffix. One is phobic, one is philic. What phobic means? Phob means hate, be afraid of. So hydrophobic means hate water. So you can correlate this term with the lotus leaf phenomenon. Philic, what the philic means? It means love. Hydrophilic, love water. So the surface will be covered by the water. The surface has affinity for water. So let us push one step further. What factor or reason caused a surface to show the hydrophobic or hydrophilic property? For hydrophilic surface, the one major reason is that there are lots of polar groups on the surface. For example, hydroxyl groups. Those polar groups interact with water molecules through hydrogen bond. Hydrogen bond is kind of bond very strong. The water can easily spread over the whole surface. But for the hydrophobic surface, one major reason is the physical reason, just like the lotus leaf example. The microscopic picture shows that the microscopic structure of lotus leaf is that this surface is really rough. And this microscopic structure turns out that the lotus leaf to be hydrophobic in macroscopic level. And the second reason is also chemical reason. The surface might be covered by the nonpolar groups. For example, the alkane. The alkane is major component making up the fat and oil in our daily life. You can imagine the fat and oil, they hate water. They cannot mix up with water. So the surface also hydrophobic. They do not like water. Maybe you will think this hydrophilic and hydrophobic, these two terms cannot exist at the same time. However, they can. This is the detergent we used in our daily life to wash our dishes. And this detergent consists of the surfactant molecules. The surfactant is a kind of molecule being composed of the hydrophilic head group and hydrophobic tail group. So, in this one molecule, it shows up two properties, both hydrophilic property and hydrophobic property. Now, this picture will show how the detergent works. The basic mechanism is that the hydrophilic group will enter the water phase, and the tail group, which is hydrophobic, will enter the oil phase. So this molecule is just like a mechanical link connecting both water phase and oil phase. When you wash the dishes with water flow, that water flow will carry the stain on the dishes or the oil on the dishes away with the help of surfactant molecules. So I think you guys will, right now you are familiar with the two terms. And next time when your friends or families asking about the questions about how detergent works, I think you can do very well in explaining this mechanism to them. Thank you.